Hi, everyone. Wish you all a very happy Mahashtami, and thanks for making this time on a Friday evening to attend this session. For those of you who don't know me, I'm Hari Balaji. I'm a partner with EY India's technology consulting practice. I sit out of Bangalore, and my areas of focus are AI and generative AI, and I work on many AI-enabled transformation mandates. On this Ayuda Puja day, what better way to honor AI, which is increasingly becoming an important tool in all our lives, and an important tool of trade, than to talk about it. Joining me today is Professor Venkat Venkataraman. He's a prominent thought leader in digital strategy and innovation. Professor Venkat is the David J. McGrath Jr. Professor of Management at Boston University's Questrom School of Business. His research primarily focuses on how companies can leverage digital technologies and develop winning strategies. He's been a key figure in advising global corporations such as IBM, BP, Merck, and others on digital transformation. Now, as the flyer of this event mentions, asset-heavy industries contribute over 75% to global GDP. And the trillion-dollar question in front of all of us is how these players can go about getting the most out of AI and Gen AI. Interestingly, Professor Venkat has recently co-authored a book, Fusion Strategy, with Vijay Govindarajan, to talk about this very topic. Professor Venkat, on behalf of the entire EY fraternity, let me extend to you a very warm welcome, and we really look forward to having this conversation with you.
Thank you very much, Hari.
Great. So let's get started. I know that you've previously written about various other topics, but I think what caught my interest most of all was I wanted to learn what made you interested in this particular topic of talking about fusion strategy, and also what led you to your collaboration with Vijay Govindarajan. I believe you've not written a book with him before, though both of you have independently written several books.
Yeah, that's a great question. Thank you. I've known VG since my days in India, and obviously when I came to the US. We both are strategy professors by and large. I got my PhD in strategy and I started teaching at MIT Sloan School, and VG was teaching strategy at Tuck. When he recently finished the book, The Three-Box Solution, and in 2017, I had completed my book on the digital matrix, we exchanged paths, reconnected, and we said, there's a lot of interesting ideas about digital innovation that we should now collaborate on a new book. Then we started asking ourselves the question, what will make this book unique and different that combines our respective interests? He comes at it purely from a strategy and innovation perspective. I come at it from my background in mechanical engineering at IIT many, many years back, later with strategy and then minoring with information technology and working at MIT for 10 years. So we said there is really an opportunity to bring new insights that focuses on the engineering aspect of the economy that has not gotten as much attention. And we said, okay, why don't we focus on the asset-heavy sectors, the industrialization, where the next wave of industrialization is going to be because of digitization with data and AI. So that's what led to the collaboration. And then we spent a lot of time, much of the interviews during COVID using Zoom and Microsoft Teams, then visiting companies, running workshops, pulling together the ideas. And then we were extremely happy with the product that came out just at the cusp of the onset of the Gen AI revolution, if you will.
Right, and I know there's a wealth of effort that's probably gone into the book, and that becomes very apparent to anyone who spends even like a half an hour getting into the depths of it. But just to sort of demystify the suspense for the audience, the book is called Fusion Strategy, right? So can you talk about the fusion of what exactly is referred to here when you say fusion strategy?
Yeah, it's a great question. We spend a lot of time trying to come up with what we believe is an interesting and important phenomenon that's going to be in the future. We said it's really not about aligning business and IT, which is where I've spent much of my career in the past, including writing the strategic alignment model and then digital transformation. What we said is there is a broader set of forces in play. It's the fusion, which is the merging of two entities, where at the end, the two entities are not obvious. It's the new creation of the third entity. That's the fusion between A and B. What does it mean? Physical and digital. Today, we can identify atoms and bits as separate, but we can begin to have discussion about what happens when you have a digital industrial product where the architecture is no longer the analog version of it, but the digital version of it. The fusion between humans and machines, the idea of human intelligence is somehow different from machine intelligence, is something we today think about it, but tomorrow, the fusion of human intelligence and machine intelligence, creating either a super agency or super intelligence, where the contribution of humans and the contribution of compute will not be easy to disentangle. Then there is a fusion between a company and its partners in the ecosystem. Every company, in my view, is a portfolio of capabilities augmented and assembled with a portfolio of relationships in different types of ecosystem. It's not just what we produce by ourselves, but how others contribute, collaborate, and co-create value. So the fusion between company and partners. Then think about fusion across disciplines. I studied mechanical engineering. What is mechanical engineering today without data and AI? What is electrical engineering without data and AI? What is material science without data and AI? And just this week, we've had 2 Nobel Prizes given to physics and chemistry,
Indeed,
which is
indeed.
fundamentally an AI-enabled fusion. So the future of physics is going to be AI. The future of chemistry is going to be AI. The future of biology is going to be AI. So to us, the whole idea of fusion is really at the center of how we should begin to think about it, rather than the independent silos and the siloed thinking that permeate organization, and in our own views, how we compartmentalize rather than integrate things. So that's the reason why we chose this title, Fusion Strategy, not so much in the sense of energy, but in the sense of a broader phenomenon of interconnections, interdependencies, and morphing of things that's right in front of us.
No, very interesting. And what also this resonated with me because at EY we've been talking a lot about how we need to approach our clients with holistic solutions, and we've recently launched this whole campaign about being all in front of our clients. So it sort of resonated very well with those ideas as well. And further, we sort of see AI as an enabler and generative AI as an enabler to everything that we do as a firm and everything that our clients do as well. So I think those themes really came across very well when I read, that section of your book where you talk about, these 5 groupings: the physical, digital, the human machine, digital, analog, physical, virtual, and amongst companies and amongst different players in the ecosystem. Now going forward, one thing which everyone realizes is that all AI starts with good data, right? And early on in this book, you very sort of, in a very lovely fashion, you introduce this concept of a data graph. Right. And what is a data graph, and can you give our listeners a specific example of what a data graph could be in a business context?
Yeah. We wrote this article in the Harvard Business Review in 2022, focused on the data graph of the asset light digital giants or the asset light tech entrepreneurs. Our idea of data graph is simply to bring attention to data network effects. right? I mean, let me explain the idea of the data network effects, which is a precursor to AI, which is a precursor to Gen AI, right? For example,
So, and when you say, sorry, when you say asset light, folks, you mean the Facebooks and the Googles of the world.
exactly, right? So these are with purely digital version of an analog product. So if you think about music, there is a music graph that Spotify essentially today masters, creating the ontology of connections across all the different type of genre of music for them to be able to create a DJ, an AI DJ to personalize music for Hari based on the mood that he may be in, right? So the idea of data graph is data network effect. So if a company has millions of customers who interact with their product or service in real time, thanks to a device called the smartphone, I understand these million customers in real time and see a pattern that allow me to predict and recommend what the million plus one customer will do, likely do, right? So the search graph for Google is before we would have 5 or 6 words before it can predict what we are really searching. Then it became 5 words and 4 words and 3 words. Now with just a few words on the search bar, they can predict what is it that you're likely to be searching for. That's a precursor to what Google has done with Gen AI, with attention is all you need paper that came out in 2012, right? So that's the knowledge graph that they have created. So these digital giants have really become masters at data and information architecture, right? There is really no AI without information architecture. And the information architecture is what these companies have mastered. So what do I mean by the data graph? And it's easy to explain by saying Google is search graph. They know what we search and they monetize it with advertising. Facebook is social graph. 3 billion people interact across 5 or 6 platforms to essentially map the social network of humans. Spotify is music graph. Amazon is purchase graph. Netflix is movie graph that makes sure that roughly 75% of what we watch is based on the first screen, which is customized for each one, based on whether we are sitting in front of large television, small notebooks, or smaller devices like tablets and phones. And most important for me is really LinkedIn's professional graph when LinkedIn subsequently became part of Microsoft. So if you think back to Satya Nadella's big, bold decision to buy LinkedIn for $15+ billion, it was not for advertising. It was his vision of connecting Microsoft Graph to LinkedIn Graph to really understand how professionals work. Today, they got over 700 million professionals on the Microsoft Graph, spending 12, 14 hours a day giving the metadata on how people actually work. So while Facebook may have 3 billion people that spend maybe 30 minutes, 45 minutes to an hour, Microsoft has data on professionals spending bulk of their time on their graph. So the data graph idea is really providing the foundation for then asking ourselves this question. As we spent a lot of time with companies, they said, oh, these are great ideas, but these are all data graph on individuals that interact over a smart device, whether it's a phone or a tablet or a PC or a wearable. What does it mean to have a data graph for industrials?
Right, exactly.
And so that's what really led us to make the transition from that chapter, which is, chapter 2, if you will, in the book, to chapter 3, where we say we can learn a lot from the asset light sectors with data and the data architecture to develop a parallel idea for the industrial sector.
Good. I'm just gonna push you a little bit there in terms of can you sort of come up with or give us one example of what a company that you worked with who's built that data graph in the asset heavy industries, who you can talk about, which you can talk about a little bit, so that our listeners get some perspective on what that data graph could look like for an asset heavy industry?
Yeah. So it's a great question. And I think the best example that I want everyone to think about is really the combination of what Tesla is doing with what does it mean for a company like John Deere that make tractors, right?
Right.
If you look
Right.
at the automotive industry, automotive industry is what I call as an industry that has a B2C brand, like the BMWs and the Jaguar, the Land Rover, and whatever else. A B2C brand with a B2B process where the data ends at the level of the dealer, not as we drive our automobile. Now, that's because the industrial age data was really focused on data in manufacturing, data at the level of design, data at the level of delivering to the dealer, not data as products driven. Learning
Right.
from the asset light, if we now bring it to the asset heavy sector, what we need is really to think about machines that transmit data in real time so that we can understand how the machines are performing on the field. So when we now look at a car like Tesla, which I've been driving one for the last 5 years, it's a car where there is real-time data back to the mothership, if you will, that analyzes how the car is being driven. And I've been one of the first ones to drive, even with full supervised driving software. And at that point in time, you realize that it started giving me a score on my driving. And the score on the driving is really not how well I'm driving. The score on the driving is computing my driving against the algorithm's prediction of how I should drive and calculating the deviation and sending the data back, right? So if you now think about the architecture of the automobile industry, it's resembling an architecture of a computer industry.
Right.
So as asset heavy sectors digitalize their product, digitalize their supply chain, they got to focus on the end-to-end data, starting from how the machines are performing on the field rather than data that they historically have, with data as designed, data as manufactured, data as delivered, not data in use. So we spend a lot of time in the book talking about data in motion or data in use. And so that's the lesson from Tesla. Now, bringing that to a John Deere example or a Caterpillar example, or it could be Mahindra tractors, to really the mindset shifts from your metric of success is not number of tractors that you have delivered. The mindset of success and the metric you need to focus on is the yield on the farm for which you have orchestrated using your machine. So if you can now collect data on how the tractors have improved the yield on the farm, and John Deere is beginning to talk about millions of engaged acres. And today, the engaged acres could be few attributes of data that they collect based on the sensors and hardware and software they can put in. But their roadmap is to collect richer high definition data on the field so that they can optimize the tractor to enhance the yield on the farm. So every asset heavy machine company, as they develop a multi-year roadmap of digitizing the product, don't just add bells and whistles of Bluetooth and fancy displays. Focus on the data that you collect about product in use and product in use that you can analyze and create your own product data graph, similar to search graph. So for a tractor company, it's the farm graph, right? For a car company, it is the mobility graph, or whatever else is the terminology that they want to use. So that's the thinking we want the asset heavy companies to take from our work so far.
Right. No, I mean, I found it to be, so what it unlocked for me, and I come from a world where I've built software products and I ran a SaaS business. I think the beautiful thing it sort of unlocked for me is that in the product-led growth world, you're constantly tracking how your users are using your product, right? And you're doing that through a Google Analytics, you're doing that through an Amplitude or a Mixpanel or various other telemetry softwares that are sort of sitting behind your product. And the beautiful thing, which I was able to see as an analogy, is that the message, at least for all asset heavy companies that are creating assets or products which are out in the field, is to be able to do the same thing. Observe your product in action, observe how your users are actually benefiting from the usage of your product, and that will teach you a lot more about how to make better products and how to, rather than just being focused on revenue as a metric. So I'll just take a pause. I do want to let all our listeners know that we are taking questions. So please do feel free to send them across. We do have a planned schedule of how we want to take this conversation forward, but I will definitely be addressing audience questions through the course of this talk as well as towards the end. So please keep them coming. Now, just to sort of shift gears, a topic that's personally very important to me, and I've had many spirited discussions about this with our clients in sort of the asset heavy industries. For a lot of them, they've seen things like supply chain optimization, predictive maintenance, demand forecasting, and various other aspects of their business where they work with data. They've used traditional operation research methods. They've used dynamic programming and then machine learning and probably even deep learning today, right, to make predictions, to work with numbers. But to a lot of them, what is not apparent is where does generative AI come into all of this? And I think you have some very interesting thoughts about that in your book, and we'd love to sort of have our listeners hear about that from you.
Yeah, great question, Hari. And part of the reason why we got excited to focus on the asset heavy sector itself is that there's a rich history of digitization in the industry, right? I mean, if you take the idea of digital twins that we talk again in the course of the book, digital twin is about 60 years old, right? We created the digital twin for really expensive, high value assets.
Right.
We have had analytics to optimize supply chain for a very long time. Ever since the Japanese introduced just-in-time manufacturing, people have spent a lot of time trying to master that data, master that. The big transformative thinking is most of the data is siloed. Most of the data is aggregated to optimize the function as it is designed today. So where does quality end and R&D begin? Where does R&D end and manufacturing begin? Where does manufacturing end and sales begin? Where does sales end and service begin? And so on and so forth, right? And because of the functional focus, and the CEOs have largely decentralized responsibility for both investment and maintenance of these functions, the individual functions have been optimized. But we all know the biggest problem in predictive analytics is not optimizing individual functions, but to optimize it as end-to-end. So I can claim that I'm 97% reliable in production. You can claim you're 94% reliable in sales and delivery. Somebody else can say they are 95% reliable in after-sales service. When you start multiplying it, you very quickly realize that we are optimizing at 70% or 72%. And the new entrants that are coming in don't have these functional silos, right? So the engineering companies have to think beyond the silos and really think about this as cross-functional.
Right.
End to end, including what I said earlier about company and the partners in the extended ecosystem, because the weakest part is not what happens inside your company, is it could well be in the ecosystem, right? So take a car and talk about the company that delivers the tires, right? So you could be Michelin, you could be Continental, you could be Goodyear.
Right.
They get aggregate data on when people change the tires. But as part of an integrated data architecture in the car, they can get real-time data on when a particular tire is failing, for what reason. Then you can start generating the questions on why do certain type of tires fail under certain driving condition, not just simply front wheel or back wheel, but understand the driving patterns and the driving condition, because that helped them figure out the next generation design of the product itself. Instead of waiting for aggregator, you now focus on fine-grained data in real time to start developing the capability to then generate alternative ways to design the product. So then I'm going to come back to this idea of digital twin. We have digital twin to make sure that we have the best product. Then we got the digital thread for manufacturing. We call that process twins. Product twins is to design the product, process twin to manufacture the product. Then we introduce this idea called the performance twin, which is your ability to collect data on your product as they are performing in the field, right? So for industrial companies, the data is really connecting product twin to process twin to performance twin, this tripartite twins, if you will. And once you connect them, you realize that you have the data to generate now answers to questions that you couldn't have done before. So we are going from essentially predictive analytic to generative options. And the generative options allows multiple functions to sit together and say, how do we optimize it as an enterprise that's extended rather than how do we optimize it as an individual function? To us, that's the breakthrough in thinking that we can get.
Very much. So, I mean, I think that was, again, a very interesting insight. If I had to sort of simplify that a little bit more, and we talk about this quite a bit within our practice, which is, I think everyone in the world today realizes that generative AI is going to help humans talk to machines. But can it also help companies talk to other companies, functions talk to other functions, machines talk to other machines? And without sort of having these very detailed schematics and rules, can I, for instance, understand what a machine is transmitting to me, what an IoT device is transmitting to me, by dynamically understanding its API documentation without having to lay the pipeline for how they will interact, how two machines will interact with each other in advance, right? I think in some ways, sort of the idea of introducing generative AI into all of these functions is really expanding the mind and the concept of helping generative AI be a communication channel between two different entities, and they need not be humans with machines. It could be machines with machines, or one function with another, or one company with another company, and sort of just making that very rule agnostic and sort of much less rigid than what it otherwise needs to be. And that's sort of what I took away from a lot of what you had to say on generative AI. Now, again,
Hari, you're absolutely right. I'll just add one more layer, which is, let's not forget the innovation that has come with the UX, which is natural language processing, right?
Right.
Before the executives that were not schooled in how to access databases had to then ask the question, somebody will have to be the translator and go look through the analytics and come back and then report out.
Yes, indeed.
Is now, that entire friction is now taken away.
Correct.
I can ask in any language, right? And as a business executive, my requirement is really to be able to think through the problem that I want to solve. And then it connects across all these different databases, across the ontology that has not been predefined, but it's able to connect. And we see that in a simple way when you see demos when somebody is speaking English and is translated into Chinese or to Hindi or to Tamil. It's the same way when it comes to generative AI, cutting across data that sits in manufacturing, data that sits in quality, data that sits in suppliers, and to connect across in a way to generate the insights for you.
Fantastic. So just sort of moving on, I think there's another question I think related to this, which I wanted to bring up. And you spend quite a bit of time talking about this in the book as well. So everyone appreciates that AI is evolving rapidly. And at least a lot of the clients that we end up talking to, they are now able to extrapolate the rapid growth, especially of generative AI, and create these amazing futuristic visions for what AI can deliver for them, right? But the challenge comes when they need to make a data investment in order to facilitate that vision. Um, Most companies today, unfortunately, especially in the asset heavy space, are not data ready. They will have to spend a significant amount of time, effort, money, resources in creating, getting data to a point where it is AI ready, right? And we have a gentleman from the audience as well who's posed a question about, if I don't have any data or I'm sort of at this point a startup, where do I even start, right? So I think so. Coming back to all of that, if I had to now make a capital investment towards, fusion strategy, I will have detractors within the firm, within the company telling me like, why are you spending all your money on this? There are easier wins. You can just upgrade an equipment or you can spend your capex on something else, right? So how do sort of business leaders deal with this conundrum where there seems to be easier, short-term wins to achieve through capex and through investment, rather than saying that, look, 2 years down the line, I'm going to become data ready, and I'm going to learn from all this telemetry that I've collected today, right? And it's going to make me a much better company. How do they sort of reconcile with this?
Yeah, I'm smiling because that's a question that comes up all the time, right? And there's one slide that I use, which is
Mm-hmm.
why do successful companies die?
Okay.
Not why do companies die, but why do successful companies die? Successful companies die because they overinvest in what they are good at today and underinvest in what they need to be good at tomorrow. The leader's
Mm-hmm.
challenge, the
Mm-hmm.
leader's challenge is not to choose the easy path of over investing in what you're good at today because it's easy to justify, but to resource reallocate towards what is needed to win in the future, right?
Right.
Leaders should recognize these breakpoints. What are the breakpoints that we see today? The breakpoints that we see today is that the analog world is becoming digital, right? This is
Mm-hmm.
no, and again, we can learn a lot from the asset light sectors, right?
Mm-hmm.
Look at photography, changed. Look at music, changed. Look at media and entertainment, changed. Look at newspapers and books, changed. Look at payments, changed, right? We can go on and look at all the asset light. And what is
Right.
interesting, Hari, is that in nearly all the examples that I gave in the asset light sector, the analog product simply became an app inside the smartphone.
Mm-hmm.
Camera is an app, book is an app, right? Music is an app, video is an app, calculator is an app. We can go and look at all the analog product that we individually used or given companies used, simply became an app. The value shifted to the one who orchestrated the platform, right?
Right.
So I could, as Henry Ford said, if you're looking at any technological development as the faster horse problem,
Mm-hmm.
when we are shifting away from a horse-drawn carriage to an
Right.
industrial machine, we would
Right.
have tried to figure out to make the horse faster, right? And
Yes.
the leaders have to essentially recognize that the biggest transformation challenge today is resource reallocation.
Mm-hmm.
That's why I say it's not a technology problem. It cannot be delegated to a chief AI officer or a chief data officer or a chief digital officer or chief whatever officer, because the moment you delegate it, you're boxing them to resource allocate in the same way that they have defined before with a little bit more money. No, this is about re-architecting the company and reallocating across the different functional silos that existed today. So,
Right.
and the three resources are really money, people, and time. Leaders should take the time and ask themselves this very important question, which is, will I be relevant in the future when
Mm-hmm.
data and AI is going to rule my world by continuing to invest incrementally in refining my current product when my current product, as it's going to be delivered in the future, will be obsolete?
Yeah,
right?
makes total sense. If I have to step back, essentially the message I'm taking away here is really that it requires CXO conviction, CXO bravery to make a difficult decision, which may be unpopular in the short run, but is critical to survival and success in the long run. That's
Absolutely.
really what I'm taking away from this.
Absolutely. And Hari, we can look back in history, right? And see people that assume future is
Hmm.
an extrapolation of the past lost
Hmm.
out, right?
Right,
When Reed Hastings walks into the Blockbuster boardroom
right,
and is prepared to give the DVD by mail into Blockbuster that was worth $5 billion, and he
right,
wanted 50 million. He just wanted 50 million to be a division inside the company to incubate that. They said 50 million. Why would I want to spend it on DVD distribution? We can do it ourselves. No, they can't do it
right,
because what Reed Hastings had was the data on how people watched movies, which Blockbuster didn't have, right?
right. Indeed. I'm just going to drill down into a slightly related question, which is that a lot of our clients, a lot of companies today, they have started dabbling in AI and Gen AI, right? And many of them have created these labs. Many of them have worked on many POC engagements, right? And what they do find is that many of these initiatives are slow. They don't live up to the promise. They take time to mature. So one specific question is, do you have any guidance for CXOs as to how to think about doubling down versus cutting their losses when it comes to
Yeah,
AI?
yeah. I think there are two issues. There are two issues that are interconnected in your question. One is I strongly believe that the only way forward for companies is to think about strategy as a sequenced portfolio of experiments to resolve the uncertainty, right? I'm using the word sequenced and portfolio, not one experiment, but a sequence of experiment, and look at it as portfolio of experiments, some that reinforce today
Mm-hmm.
and many that challenge and create the tomorrow, some that you do inside the company, some that you do with partners, but and make sure that it is sequenced, right?
Mm-hmm.
And so if you now think about Ray-Ban and Meta as an example of what the future of the glass will look like,
Mm-hmm.
Luxottica realized that the future of glass in a digital world and a data and AI centric world is going to be very different than the vision correction glass that existed in the analog world. So in the first generation, they were working with Meta while Meta was trying to figure out how to put Llama into the glass. Now,
Mm-hmm.
this is a 10-year horizon, right? That experiment for Meta with Luxottica allows them to take the idea that otherwise would have been a purely asset light experiment
Mm-hmm.
into an asset heavy, relatively speaking, asset heavy because of the physical product. And for Luxottica, they could do that by essentially looking at their internal AI people, because they're
Mm-hmm.
never going to have the level of AI capabilities and skills and expertise that what Facebook Meta has, right? So that
Right.
portfolio of experiment. So it's a sequence of experiment. The first version of Ray-Ban smart glasses is not what is going to happen today. It's going to be different when Orion comes out and the next version comes out, right? So that's important to look at this as a sequence of portfolio of experiment. The second, and maybe more important for CEOs, is to have the discipline to recognize that the prototypes are not the same way that is going to be when it is scaled up.
Right. Indeed.
And you cannot design prototype as an experiment, as just a proof of concept of the idea without thinking through how you're going to manufacture, how you're going to deliver and collect the data from use. And most prototypes today that I've looked at, they only show the proof of concept of the possibilities.
Right.
I'm saying that's necessary, but give me the sequence of experiment roadmap to tell me when it's deployed at scale, how are you going to use the data to then make yourself be indispensable in that
Uh-huh.
future rather than simply show me that the prototype works. Because the prototype is easy.
Right.
And the shining object is not the answer. Shining
Right.
object is the proof of the possibility. Show me
Right.
what the end result look like, right? And the
Right.
CXOs are beginning to recognize that these wonderful experiments are shiny showcase that you can show for
Mm-hmm.
investors and get people excited about it. But I'm
Right.
much more interested as a strategist for you to show me the roadmap to profitability.
Right. Right. No, makes complete sense. Just drawing a little bit on audience questions. I mean, you did mention, I think John Deere, Tesla, and a couple of others, but would love to sort of hear from you some companies which both large and small, who have done a good job in what you would call fusion strategy.
Yeah, I think, well, I'll give you a few examples, but I encourage the
Yes.
listeners and the readers to just think a little bit about the art of the possible, right? And what
Mm-hmm.
is holding us back in terms
Mm-hmm.
of creating a fusion product, right?
Right.
Take a simple example like Honeywell thermostat. That's an
Okay.
analog thermostat, and
Right.
then Nest came with the learning thermostat. Nest is now part of Google that created the Google thermostat. So
Right.
thermostat is essentially an analog product that's now become a digital product. And Honeywell said, there is no way in which we're going to scale this up, and they spun it out as a separate entity, right?
Right.
Take a speaker.
Mm-hmm.
Bose makes fantastic speakers. Harman Kardon makes fantastic speakers. But all of them is based on analog sound engineers that look
Mm-hmm.
at a speaker as an output device with high fidelity sound because they're all sound engineers. But tomorrow, a speaker is an input output device, like what Amazon does with Echo, right?
Right.
Alexa.
Right.
Or
Right.
what we're going to do with all our devices are going to be input output device. So speaker is part of the interaction where
Right.
you need more than sound engineers to understand the natural language processing of making this connection. So these are all fusion products, right?
Right. Right.
Uh, and you think about a building. I've got this a wonderful company in Silicon Valley called View Glass. The View Glass is a big sheet of glass in airports, hospitals, university buildings, in which it's automatically tinted based on the sun glare,
Got it.
and the glass can be used for multiple purposes. It can be used
Right.
as projection displays. It can be used to control heat and cool, and based on the
Mm-hmm.
number of people in the room, it can adjust. So the glass is not just a glass, but it's a smart glass that adapts to the user environment.
Right.
And people love it because you don't have to put blinds, right? It adjusts to the functionality.
Makes
It's
sense.
a
Makes sense.
fusion product.
Right.
A building is a fusion product. Aircraft
Right.
engine, Rolls-Royce, we talk about that in the book. Rolls-Royce
Right.
is a fusion product.
Right.
Earth moving equipment from Caterpillar is a fusion product.
Right.
Hitachi Rail, Siemens Rail, an engine, railway that works on rail is a fusion product where the
Right.
ball bearings are analyzed in real time, right?
Right.
Solar grid and energy is a fusion product.
Right.
Essentially, in my view, you look at a company like Samsara that puts IoT device on
Mm-hmm.
physical assets. That's
Mm-hmm.
now become a $25 billion company by
Right.
essentially making a physical product with transmission capability with today's IoT and
Right.
project what they could be in the next 5 years on
Right.
providing high definition, high fidelity, high resolution data, right?
Right.
Monarch Tractor, a new startup that is essentially designed as a digital industrial product.
Right.
I mean, I can go on and talk about all that is possible today, but it
Right.
changes, Hari, the mindset by don't just let a mechanical engineer like me work in silos. Get a mechanical engineer working with a software engineer, a telematics engineer, and a data and an AI engineer and ask, what will the design of this product look like in the future?
Right.
And what is holding us back? When can we make it commercially viable? What is required in the ecosystem for it to become relevant and possible, right?
Right.
And that's where the sparks start to come in, is when you look at and say, people ask me, could Uber have been created in the year 2000? The answer is no. There would be no Uber without a smartphone,
Right.
without having the 5G networks that make the latency so low that I can actually feel confident that the car is around the corner.
Right.
Without 5G and the smartphone, I would never feel comfortable. So
Yes.
all of these are convergence that's making the fusion strategy possible. And then once we get to the tipping point, we will scale up at an exponential pace. That is what is exciting to me, because there is something like $75 trillion worth of GDP that's asset heavy sectors, that's
Right.
digitized in parts.
Right.
Like you said earlier, digitized in supply chain, digitized in quality, digitized in production, but
Mhm.
not digitized end to end.
Right.
That's where the real breakthrough is going to happen. That's where the opportunities lie.
So at this point, I want to jump in and ask an important question, which I'm sure many of us in the audience are thinking about, which is, while manufacturing is a large component of, or asset-heavy industry is a large component of global GDP, India is still very much services-led, agriculture-led. Uh, if you're a company in India in the manufacturing segment or in the industrial segment, what does it mean for us, and what should we be really going after? What should be our focus today?
Yeah. So I think, I think for the Indian version of the book, we wrote a preface that's really focusing on India. And, for those of you who get copies of the book in India, you'll find that issue, because that's
Right.
really very close to VG and my heart.
Right.
We believe that if by 2030, most people estimate that India would not only be the third largest economy in the world and the third largest stock market in the world, it cannot come only with service-led transformation.
Yes.
It has got to come with the next wave manufacturing.
Right.
Just like what China did to create its manufacturing, which I call as manufacturing 1.0, which is largely on the back of low labor cost, and then obviously it's moved up in high value. India has an opportunity to create manufacturing as a digital industrial discipline rather than traditional engineering discipline. Fusion, where the next generation mechanical engineers don't create the siloed thinking like I was taught, which made sense in the 1970s as a
Yeah.
mechanical engineering discipline or a civil
Right.
engineering discipline. Cement has got a data and analytics component. Machinery has a data and analytics component. India's manufacturing in the next 10 years has got to be a digital industrial manufacturing backbone. When that happens, Make in India is not simply a low cost play, but it's a smart data and AI play where the industrial manufacturing with digital services fuse together to unlock the value and deliver that value to on the global marketplace, right? I believe that India can come up with wonderful set of prototypes, but can it scale up and be seen as a legitimate global player leading the digital industrial transformation? That's for people like you, consultants. There are lots of people in the audience that are listening to it. That's the future, right? I say, as I turned 70 this year, I said, I wish I was 30 years younger, where I would have a very different view on the possibilities of India on creating the fusion future, where the blurring of boundaries between functions, industries, um, and the thinking will no longer exist, where we'll unlock value that exists today in these trapped silos. I wish I was 30 years younger, but I'm sure a lot of people in the audience that are much younger than me will see that becoming a reality over the next 10 years in India.
No, it's a very reassuring thought and message, and let's hope it all comes true. Very well said, Professor Venkat. We're almost up on the hour, and thank you so much for spending the past hour with us to talk about your book and about many other ideas. I really enjoyed the past hour, and I hope that our audience members did as well.